Find the length x along beam AD where the shear equals 0 kips. In this problem, the beam AD includes a point load P of 4 kips at point A, a pin connection at joint B, a continuous load W of 2 kips per foot from point C to joint D, and a roller connection at joint D. Lengths AB, BC, and CD are spaced 8 feet apart, and the length x begins at point A and increases in the direction of joint D. To find where the shear in the beam equals 0, we can sketch out the shear profile of the beam. To do so, we first need to calculate the vertical reaction forces at joints B and joint D. Summing the moments about point B, setting the value equal to 0, solving for the vertical reaction force at joint D, and plugging in the values for the point force, the continuous force, and the spacing, the vertical reaction force at joint D equals 10 kips. The vertical reaction force at joint B can be solved by summing the forces in the vertical direction, setting the value equal to 0, and plugging in the appropriate values. The vertical reaction force at joint B equals 10 kips. Returning to the shear diagram, we'll begin at point A, at the left end of the beam, and sketch the shear profile along the beam. Since the point load P is the only force acting on the beam from point A to point B, the shear force over this length is -4 kips. The shear force between joint B and point C equals the shear force between A and B plus the vertical reaction force at joint B, which equals 6 kips. Lastly, the shear force in the beam between joints C and D equals the shear force at point C plus the continuous force, W, times the length of the continuous force. To find the shear just left of joint D, we can set x minus x sub c equal to the entire length of CD, D. And the shear force just left of joint D equals -10 kips. This makes sense because the vertical reaction force at joint D also equals 10 kips. The question asks to find the length x along the beam where the shear force is equal to 0, which occurs only at the 3 locations circled in green. When looking at our possible solutions, we notice answer A of x equals 11.2 feet cannot be correct. The first and third green circles are at lengths x equals d and x equals 3 times d, or 8 feet and 24 feet, neither of which are possible solutions. Therefore, we know x equals the length from point A to the second point in the beam where the shear force equals 0 kips. Returning to our equation for the shear force along member CD, if we solve for x, set VCD to 0 kips, and plug in the other values, the value of x equals 19 feet. When reviewing the possible solutions, the answer is B.